This is section 5, definition of a derivative, example 1b and d. All right, so for part B, we are doing the exact same thing that we did in part A. We're finding the limit as h approaches 0 of f of x plus h minus f of x all over h. So the first thing I always want you to do is write down that formula. It's going to help you remember it. So we're finding f prime of x, and we find that by taking the limit as h approaches 0 of f of x plus h minus f of x all over h. Now, this time, f is just 4x. So that's going to make this a lot faster, so much simpler of a process. And it's not asking us to find f prime of any numbers. It's just asking us to find the derivative. So it'll be, like I said, easier and faster. So we're finding the limit as h approaches 0 of 4 times x plus h minus 4x all over h. That's the substitution. Very, very simple. All right, then we distribute. So we have the limit as h approaches 0 of 4x plus 4h minus 4x all over h. Well, you can see right now 4x minus 4x is 0, and so we have h over h. Well, h over h cancel too. So we're really just finding the limit as h approaches 0 of 4, which ends up being 4. That's it. That's the answer. Okay, so it's easier when it's linear. In part C, it's x squared plus x. I already did an example like that. It's part A. So if you want, what you should do is go ahead and pause this and try part C the same way that I did part A. The answer ends up being 2x plus 1. Okay, so try it and see if you get that. Now part D is a fraction, and so it's going to take a little bit more work. It's going to be a little bit more like that problem that I did in section 4, where I used a fraction. So let's go ahead and do part D. We're still finding the derivative, so let's find y prime, and it's the limit as h approaches 0 of f of x plus h minus f of x all over h. All right, so we're plugging in x plus h into the equation, and then we're plugging in x into the equation. So we get 4 over, I forgot. We're finding the limit as h approaches 0 of 4 over x plus h minus 4 over x all over h. Now, just like last time, in the last section, we're going to have to take these fractions, and notice they have nothing in common in the denominator because remember, addition causes things to be completely different. So we need to make a common denominator. The only way to do that is to multiply each fraction by the other one's denominator. So I'm going to take the first fraction and multiply by x. I'm going to take the second fraction and multiply by x plus h. That's going to make the denominators both x times x plus h. So let's go ahead and do that. We'll go ahead and simplify. We have the limit as h approaches 0 of, 4x. Now remember, it's minus 4 times x plus h, so we're going to distribute the negative 4x here and here. So it's going to be negative 4x minus 4h all over x times x plus h. And that is all over h. Now we know immediately by looking at this that those two things cancel because 4x minus 4x is just 0. We also know by the last video that you're allowed to take this h and pull it in front. So when I do that, I get the limit as h approaches 0 of 1 over h, because remember, when you divide by a fraction, you're actually multiplying by its reciprocal, times negative 4h over x times x plus h. Now there's an h on top and on bottom right here, and I'm allowed to do that because it's separated by multiplication. I could not take the h in the numerator and the x plus h in the denominator and cancel those. That is not allowed. Remember, that's against math law, okay? You cannot do that. But now I'm going to simplify as best as I can. I'm going to go all the way back over to the other side. So you have the limit as h approaches 0 of negative 4 over x times x plus h. Now remember, when I take the limit, I'm taking that 0 and plugging it in for h. So I'm plugging that in right there. When I do that, I end up with negative 4 over x times x, which is x squared. And that is the answer.